screen visible? Screen is
Yes.
visible?
Yes, sir.
So the last class we have discussed about what is a network and what are the network hardwares are there. If we are having network hardwares like computer is present and communication where there is our communication medium is present, then how to connect in between themselves. That also we have seen with by the help of different topologies. Then the next one is we are starting with today. That is a network software. So once we are having the hardware is ready, then we need a software to run that hardware. Without software, the hardware will not. That we know it previously also. Whenever we have started studying about normal computer, then also whenever we are having a computer with us, that means only I'm talking about the hardware part, that computer with us. Then whether it is going to run by itself, no, directly it cannot run by itself. Whenever you are buying a computer, then directly it cannot run. To run that hardware, we need a software. If the software is installed on that hardware, that means in our computer, if operating system is installed, operating system is a kind of system software. So if that system software is installed in our computer, then only the hardware can run. Otherwise, the hardware cannot run. So here also, in case of our network, the same concept is there. If we are having the network hardware is present, then also we need the network software so that the network hardware can run. Okay. So for that, whatever the softwares we need here, we need mainly the protocols. Whatever the protocol we are going to use, that protocol is called as a software. So that protocol, whenever we are using, this protocol is telling us that what kind of rules and regulations are going to be followed during the data communication. Okay, so that is the software we are going to use. Okay, so we can see here whatever the protocol hierarchies are there, how we are using a hierarchical manner, we are using the protocols. Then the design issues of the layers, whatever the design issues are there with the layer, that we'll see. And connection oriented versus connection less, only these two concepts we know now. But in the future, we'll go in detail about whatever the connection oriented protocols are there, whatever the connection less protocols are there, how they are helping us, that will in detail. Okay. And the service primitives, we are using some service primitives that we are going to see. And the relationship with the services to the protocols. How the services will be given by the protocols, that we are going to see. Okay. So all these concepts you can go through the Tannenbaum book. Okay, I have told you that we are following two books. One is the Tannenbaum book. Okay, you can see here also the name of that book is written Computer Networks, fifth edition, Andrew Tannenbaum and David Witherell. Okay. So this book you can follow for this first module. Then whenever I'll follow from the Porojan book, then I'll tell you that those concepts you can follow from the Porojan. Okay. So now before going to the detail of this protocol hierarchies, I want to tell you some more concepts regarding this networks and communication. Okay. So whenever we are we have discussed about how the data communication is possible. So during the data communication, mainly a sender will be there, a receiver will be there. Then the message it should be transferred from sender to the receiver by the help of a medium, and the protocol is giving us the stepwise manners like step 1, step 2, step 3. It's giving us the rules and regulations to be followed. Okay. So these are the 5 terms. It is very much needed whenever we are going for the data communication. The receiver, then message which is going to be transmitted, then the protocol and the transmission media. So these are the 5 terms. You should always remember that whenever we are going for a data communication means, then we need the 5 terms. Okay. So those 5 terms always it will be helpful whenever we are going for the data communication. Then whenever we are going for the actual data communication and the data communication is in place, that means we are going to sending or receiving the data item, then some characteristics we are going to follow. Okay. We are going to meet some characteristics. What are the characteristics we are going to meet? The first one is the delivery. Delivery means the system must deliver the data to the correct destination. Whenever we are talking about delivery of the data packet must be delivered to the correct destination. Okay, we don't want that it should be delivered to the incorrect. Okay, it will be a wrong destination. It should not be delivered. That is our first aim. And second aim is how much accurately it is delivering. The system must deliver the data accurately. Okay, it is not having any kind of fault. Okay, so then we can tell that the accuracy is 99% or 98%. Nowadays, you can tell that whenever we are talking about this COVID-19 vaccines, we are telling that the accuracy is for some of the vaccines, it is 90%, 94%, 85%, 81%. So we are telling like that. Okay, so accuracy, how much accuracy we can get in case of our data. Then the timeliness. Okay. So the system must deliver the data in a timely manner. It is not having much more delay. Okay. So if it is just transmitting the data in a timely manner, then we can tell that our data communication is going on to timeliness. Okay. Then the next one is jitter. This is also a very important term in case of data communication. Okay. So the jitter is the variation in the packet arrival time, or we can tell it as the variation in delay. Whenever we are sending a packet or we are sending more than one packet, all the packets they will not have the same delay. There will be a little bit of variation in the delay time. So that's why the arrival time, the timing will be different because delay is different. So that's why the arrival time is also different. So that variation, whatever we are getting, that is called as our jitter. You can take one example, like some packets arrives at 30 milliseconds and some arrives at 40 milliseconds. Okay. So this kind of concept, this kind of characteristics is called as jitter. Okay. It should not be that much of too high of jitter. Okay. So these are the different characteristics we are getting, like the delivery, accuracy, timeliness, and jitter. So performance, whatever we have seen here. Okay, so the performance, whenever we are talking about, then the performance can be of, it depends on the number of factors. Okay, whenever we are talking about a network and what are the network criteria we are following, it will be like we are going to follow the performance. Okay, so it is going to be dependent on a number of factors, that is including the number of users, how many number of users are there, then the types of transmission medium used and the capabilities of the hardware, whatever the hardware we are using, okay, how much capable of that hardware is, that we have to know. Then the efficiency of the software, whatever the software we are using, how efficient the software. So these are the terms they are used or they are dependent whenever we are calculating the performance of the network. Okay. And the performance of the network, it can be measured in many ways. We can just counter some of the ways like transit time. So whatever the amount of time that is required for a message to travel from one device to another device, that is called as transit time. Okay, whenever you are traveling from one place to another place, how much time you are taking, that kind of time is called as transit time. Then the response time. So whatever the time is difference between the request and response. Okay, when the user has sent a request and when it got back the response, the difference between that request time and the response time, that is called as response time. Then we can calculate the throughput, that is the number of packets transmitted. Sometimes we are calculating also number of bits transmitted per second, that can be called as. Then the delay in milliseconds. Okay, so how much delay is there for each packet? How much time difference we are getting? That kind of delay we are calculating. Okay, so these are some kind of criteria, network criteria we are following whenever we are talking about we are calculating the performance of the network. Then one more network criteria we can check, that is reliability. The network reliability, that means you can tell that how much reliable our network is, that can be measured by the means of frequency of failure, how frequently our system is getting failed. So that frequency, if it is less, then our reliability is more, because we know that our system is not getting a lot of failures. Then the time it takes to recover from the failure, that is also another important one. Okay. In that case also we can tell it as a reliable, because if it is taking very less time to recover from the failure, then we can tell that that network is a reliable. Okay. So this kind of things, it just gives us the option that we can just have trust on that on trust on the network. That means if at all I am having any failures, then I can be recovered. That is one. Second one is the frequency of failure will be very less. Then only we can tell it as a reliable network. Then the next criteria we can talk about the security. Sometimes what happens, we have to protect the data from the unauthorized access. Okay. If the authorized users are accessing the data, then there is no problem. But sometimes what happens, unauthorized users going to access our data. So that we have to protect. Otherwise, we can tell that our network is unsecure. We have to always secure our network so that whatever the data is transmitted through the network, it is safe. So that kind of network criteria is fine. Okay. Then the transmission mode, whatever the transmission mode you can see, whenever we have a transmission medium in place. Okay, transmission medium means we are having a wire is connected in between two devices. Then how they can communicate among themselves. They are having the transmission medium in place. Both the sender and the receiver is ready. Then also the transmission mode, we are having three types of transmission mode. One is called as simplex, another one is half duplex, another one is full duplex. Okay. So this simplex means it will be one-way communication. Okay. Half duplex means both the way communication is possible, but one at a time. Not both the communication is possible at the same time. And half duplex means two-way communication is also possible. For these three things, I'll give you one example. Simplex is you can take one example of your cable TV. Okay. So in cable TV, what about the connection you are getting from the cable network operator? In that case, it is like a simplex communication, one-way communication only. That means the transmitter is always the cable operator and the receiver is our TV. Okay. So two-way communication is not possible. From our TV, we cannot send any signal to that. Okay. So that is the example of simplex. But in case of half duplex, this is the example of walkie-talkie communication. So in walkie-talkie communication, both the persons can communicate, but not at the same time. One person is communicating means then other person has to only hear that. Once that person has completed its communication, normally what happened in walkie-talkie communication, at the end they will tell that over. Okay. So once this over will be told by that person, then the other person will tell the communication. Okay, it will start the communication. So that is called as half duplex. Then full duplex communication, you can take the example of our normal telephonic conversation. So during the telephonic conversation, two persons they can talk at any time. Okay, nobody can tell that no fast travel. I will tell and after that. Okay, so everybody can talk at any time. So that is example of full duplex communication. So whenever you are having devices are ready, transmission medium is ready, then also we can follow different types of transmission connectivity. Okay. So this is the example how the direction of data we can get in case of our simplex communication. This is half duplex communication, either this direction or this direction, and in full duplex in both the way we can follow. Okay. So we have already discussed about the topology. Then what are the devices are there in computer network we are using? You can just remember some of the devices. the devices names like network cables, then distributors, routers, internal network cards, whatever I have already told you, NIC, network interface card, external network cards also you can use. So these are some kind of hardware that is required to set up a computer network. This is the example of one of the NIC, network interface. Okay. And these are the example of network cables. Then these are known as the routers. Then internal network cards. These are internal network cards. These are external network cards. So in this way, we need the hardware which are needed for the computer network. And whatever the devices we need are routers, gateways, repeaters, bridges, hub, and modem. Okay. So routers means the same thing, like it is like a hub only, but hub is working in the layer 2 device. Okay. But the router it is a layer 3 device. Okay. So hub means whenever we want to connect more than one computers, we can connect to the hub. But hub is not one of the intelligent device, but we can have intelligent device like a bridge, switch, routers that are just the more advanced versions of the hub. Okay, so bridge is the next version of the hub. Then from bridge we can get the switch. So from switch we can get the routers. And modem is, it is for the modulation and demodulation. It is doing. Okay, so whatever the concept of modulation and demodulation, modulation means whatever the signal we are getting, if we want to strengthen that signal by the help of any carrier signal, so we are adding some extra thing which can be called as a carrier. Okay, original signal will be there and one carrier will be added so that it will be strengthened. It will not get weakened very easily. Okay, so that kind of concept will be called as modulation. Okay, and whenever the receiver at our home, whenever we are connecting to the internet, we are getting a modem. Okay, all of you must have just know about this modem concept. Okay, maybe you have heard somewhere that we are having a modem in our house. So that modem is modulation and demodulation device. So what it is doing, whenever it is sending any signal, then it will be that signal will be modulated, and demodulated means once we are getting the signal which is just modulated with the carrier frequency, whatever the original signal we have, one carrier frequency will be added so that it will be strengthened. And whenever we are getting that strengthened signal in our device, then we have to demodulate that so that we can get the original signal. Okay, so that is the job of our modem device. Then what is the job of repeater? The repeater means whenever our signal is transmitted through the wire, then after it is transmitted for some distance, that signal is going to be attenuated. One term you can remember, that is known as attenuation. That means it will get weak. If I tell you to run for 1 kilometer or 2 kilometers, then after running for 700 meters or 1 kilometer, depending on your strength. Okay, some of the friends, some of you may get attenuated after 500 meters or so, after 300 meters or so. Even if some of the persons will be there who can only run up to 100 meters, not more than that. Okay, so after that, whenever you are feeling tired, that signal also it is feeling tired. It cannot go beyond that device or beyond that distance. Then at that time, what we have to do, we have to regain to the original signal. So that is the job of the repeater. Okay. So what the repeater is doing, it is just regaining the whatever the attenuated signal is there, that signal will regain it to the original form. Okay, it will come back to the original form, so that the repeater is just adding some signal strength to that signal so that it can become the original signal. Again, it can transmit up to, it can travel up to another 1 kilometer. If it is getting attenuated after 1 kilometer, then in each 1 kilometer distance, we have to put one repeater. Okay. So these kind of repeaters you can see through the cable network. So whenever you are seeing the cable network in your city, then in that cable network, normally you find out the cable wires, it is just kept in the normal whatever the electric poles are there inside your city. So in that poles only it is going to be traveled. So after some distance, you are finding out that one box is there. Okay, so that wire is having the input to the box. Again, the same wire it is going as an output from the box. Okay, and you are not getting that that box is for giving connection to any of the household. Okay, only in the middle of the road or in after some distance that box is kept where that wire is given as the input. Again, another wire is given as the output. So that is known as the repeater. Okay, it is just regaining the strength of that frequency. Whatever the signal is transmitted, now it is got to the original form. Okay. So these are some kind of devices we are using. Then use of network we have already seen. We can see some more use of the network like resource sharing, information sharing, communication like email, message broadcast, then remote computing, distributed processing. For this purpose also we can use the network. Okay, if we are having any resource, that means I am having a computer. I want to tell that if anybody else want to use my computing resources means my CPU is having very high strength CPU I have, but I am not utilizing to the maximum. Then another person who needs maximum utilization of my CPU, they can also share my CPU. It is the computing resources can be shared. The disk, hard disk can be shared. The printer can be shared. The application software I have installed one of the software which can be shared by anybody else. So that kind of a resource sharing is done by the help of the computer. Then information sharing, like if I have a file or database that is needed by any other system, that can be also given by the network. Then the next one is we can go for a search capability. If we want to search on the internet, that can be also done by the help of the www, that is World Wide Web. So from that also we can get some information which is needed for us. And for the communication purpose, email communication is there, message broadcasting is there. We can use for the communication in the network. As well as remote computing. If I want to compute anything in a remote device, that is also possible by the help of network. And for our distributed processing, if I have a very large task, I want to divide it into small tasks, then the small task will be given to different machines, and in that machines it is going to be executed. So that kind of concept is called as a distributed. Okay. So categories of network that we have already seen in the last class. Okay. So only one more concept I want to tell you, that is the virtual private network. Yeah, in addition to the LAN, MAN, one personal area network PAN. So you can also use virtual private network as a VPN. It is a computer network in which some of the links between the nodes are carried by the connections, open circuits in some virtual network. We are going to create virtually one network will be created, okay, instead of by the physical wire. Okay, if in physical wires we are differentiating, then we can tell that it is a different LAN, that is a different LAN, that is a different LAN. But virtually we are creating some groups, and we can tell that this is one private network, this is another private network. Virtually we are creating that one. Then that kind of network will be called as a virtual private network or VPN. Okay, so this is another example of enterprise private network. The enterprise private network is a network which is built by an enterprise to interconnect the various company sites. If they are having different sites all over the globe, then they can create their own virtual private network. So that will be called as an enterprise private network, because that private network only can be used for for that company or that organization. So that kind of network is called as enterprise private. Okay. Then I'll come back to this place. So here I'll come to this place. Protocol hierarchy. So what is the meaning of this protocol hierarchies? Meaning of protocol hierarchy means we are going to follow certain hierarchy. That means you know that everywhere, whenever we are following a distributed architecture, then the hierarchy will be there. As like in our government, you can take one example of the government. So in the government, whatever hierarchy we are following, if we are talking about our central government, then in that central government, we are having the hierarchy of prime minister, then other cabinet ministers are there, then the state ministers are there, then some statutory body is there. So in this way, the hierarchy is there. So in the top hierarchy, the prime minister will be there, then the cabinet minister will be there. So in that way only we can get the hierarchy. That means they have to follow that hierarchy. Okay. So here also, in case of protocol hierarchies, we are having, if we are taking an example of physical medium, so from the physical medium, layer 1 can be connected, from layer 1 can connect to layer 2, from layer 2 can connect to layer 3. So whenever we are communicating in between two layers, you can call that there is one interface is present, that is layer 1 to interface. That means by the help of this interface, layer 1 and 2, they can communicate with each other. So in this way, layer 2, 3 interface, layer 3, 4 interface, or layer 4, 5 interface. Here we are just showing one example of 5 layering concept. Yeah. And here you can see if this is host 1 and this is host 2, here we don't consider it as a sender or receiver because we don't know who is the sender, who is the receiver. So we are telling that one is host 1, another is host 2. Both of them, they are having the same hierarchy of the protocols. So here we are using 5 layering concept for host 1 as well as for the host 2. So in each device, that means in each host, the layer 1, they will have the same set of protocols. That's why it is called as layer 1 protocol. So the same set of protocols will be followed in the layer 1 here. So in layer 2, the same set of protocols will be followed. In layer 3 also, the same set of protocols will be followed. So in layer 4 and layer 5 also, whatever the protocols we are following in both the devices, it will be. So now you can take an example of how actually we are going to start with the communication in two different devices. So in this case, now you can take an example like here in location A and here in location B. So what we are going to do here in location A, we are having the message I like rabbits. This message is going to be transmitted. Okay. But this person, it can only transmit to the Dutch language. Okay, so it is called as the translator. This is the translator is working here. So this translator is converting this message to Dutch language. The information for the remote translator. What is that information? You can see here for this whole message, there are two parts. One part is, it is written as L colon Dutch. That means the language here it is used as the Dutch, and in that language it is changed this message to this message. Then it will be given to the actual person who is going to send the information or whatever the message is there, it is going to be sent by the person that is called as the secretary. Okay, so in this office, this is the secretary, it wants to send this message. The message, now whatever we got this message, now it will be added with a fax number. Okay, so to which fax number it will be dialed now, that fax number will be written here in addition to the whatever the value is there. So you can just see that what we are doing here. Here actually the original message is this much size. Now what happened? If the original message, which is converted to the Dutch language, another message is added that is known as the header. Okay, this will be called as a header. Okay, so in this header, whatever header contains some more information about that message or data type. Okay, so here it contains some additional information about the message. Now, this much will become as the whole packet or whole message for this layer. Here we are considering three layers: layer one, layer two, layer. Okay, so for this layer, this much of information will be called as the whole packet or whole information. In addition to that, we are adding another header that is having the number of facts. Okay, so now after this much of information is ready by this secretary, then this secretary is going to say this is the actual message will be transmitted in the transmission medium, and it will reach to the secretary of the other device in the location B. Okay, so now whenever the secretary will receive this message, it knows that whatever the fax number is there, this is the correct fax number it has received. So it will transmit the message except the fax number information. Okay, so the fax number information now will be deleted by the secretary, and the rest of the things it will be given to the translator to the layer 2, which is present in the layer 2. It will be given to that. Then now the translator can see that this message is written in the Dutch language. So it is going to convert it to the whatever the language which will be understandable by the receiver or at the next layer who is there, who can understand which language that the person can understand. It will convert into that language, and it will delete this message or this header part. Whatever the extra information was added by this translator, now that extra information part will be deleted. Then the rest of the things it will be converted in which language it can understand. In that language it will send to the field. Okay. So this is the way how the data transmission takes place in a normal way. Normally, you must have seen the example. Whenever the other country heads are coming, like prime minister or presidents are coming, then if they don't know about English communication, because nowadays in most of the countries you can communicate in English, but if you are talking about China, then they will not consider your English communication. They only consider their Chinese communication. Okay. So whatever they are going to tell, we have to communicate with themselves means then we need a translator. Okay. So in that case, what happens? In this way, the translation goes on. Normally, whenever the person is telling something, then the translator will translate and it will tell to the other person. So in that only it is working how the protocol hierarchies are there and how we are getting that benefit. So you can take the example how the headers are added. Whatever I was talking about, this one is a header, this one is another header. So here the headers will be deleted. So how that concept is working here, that we can see. In the layer 5, the actual message is there. So that message now it will be added with one of the header which is from the 4th layer. So that's why it is called as H4. So H4 will be added to the message M. Then whenever we are going to the layer 3, so in layer 3, now you can see this message size is now it is a bigger size message which cannot be transmitted through the network or the transmission. Then now this message is divided into two parts. In one part, the header portion is because here this one is considered as the whole message. Whenever it is coming from this layer 4 to layer 3, then we are not differentiating between the actual message and the header. So now the whole size is this much. So from this size, we are just dividing it so that we are getting a header and the M1 part in one side, and the rest of the part is called as the M2 part, then it is another side. Now header 3 will be added to this portion, and also header 3 is added to this. Okay. So for this portion also the same thing is happened, like header 3 is added to this portion and this. Now we are getting, we are coming to the layer 2. So in layer 2 here, whatever the portion we are getting from this the layer 3, that is M1H4H3, M1H4H3 is there. Now what we are doing, we are adding the layer 2 concept. So in layer 2, we are adding a header 2 as well as one trailer 2 we are adding. Okay. So why this trailer 2 is added? This trailer 2 is added because header is containing some more information about that packet. That's why that header is added. Trailer is added because it contains a lot of information regarding the sender and the receiver, as well as it contains a lot of information about the whatever the problem error we are getting, right? During the data transmission, if you are getting any error, then that error control information or the flow control information that will be added in the trailer. So whenever we go to the actual communication based on the OSI reference model, then we can see that in the second layer only the trailer will be added. In none of the other layers trailers is added. Only in the second layer, that is called as the data link layer, in that layer only the trailer will be added. So that's why this information is shown. Okay. So this much all about today's whatever we are going to discuss. Okay. So now we'll stop here. Then in the next class we will start with the whatever other things are left, like service primitives, connection oriented and connectionless. Then finally we'll start with the OSI reference model and TCP. Okay. So do you have any doubts? What about the concepts we have discussed in today's class? Do you have any doubts? Okay, let me download the attendance sheet. Yes, it is downloaded. So if you don't have any doubts, then thank you all. Now you can leave.